The magic of light, introducing fiber optics. What are fiber optics? They are tiny tubes. These tubes are made of glass or plastic. They are as thin as a human hair. Fiber optics carry information. They use light to do this. Not electricity, but light. This light travels very fast. It's amazing science. These special threads are helping us send messages all around our planet, and they do it with incredible speed and clarity. Why use light? Light is super fast. It is the fastest thing there is. So information travels quickly. This is good for the internet. It is good for TV signals. Light can travel long distances. It doesn't lose much power. This means strong signals everywhere. Think about watching your favorite shows without them stopping to buffer or talking to someone far away without a delay. That's the power of light speed data. How does light stay inside? The fiber is like a pipe for light. Light goes in one end. It bounces off the inside walls. This happens again and again. The light stays trapped inside. It travels all the way to the other end. This keeps the signal strong. It's a clever design. This principle ensures that our digital messages, our videos, and our calls reach their destination without getting lost along the way. Where are fiber optics used? They are used for the internet. They help send data across the world. They are used for cable TV. This gives us clear pictures. Phone calls also use fiber optics, especially for long distances. Many modern things need them. They connect us all. From the deepest oceans to the busiest cities, these light-carrying cables form a vast network that powers our digital lives. How light travels. Reflection and fiber types. Light in a fiber doesn't leak out. It stays inside because of something cool. This is called total internal reflection. Imagine throwing a ball inside a long pipe. If you throw it at the right angle, it keeps bouncing. It doesn't escape the pipe. Light does something similar in the fiber. It hits the wall and reflects back in. This is the secret to how fibers work so well. Think of a shiny mirror. Light bounces off a mirror, right? The inside of the fiber optic cable acts like a perfect mirror, but it only works if the light hits it at a shallow angle. This special bouncing keeps the light energy focused. It guides the light along the fiber's path. This is why fiber optics are so efficient. Very little light is lost during its journey through the cable. There are different kinds of optical fibers. One type is called single-mode fiber. These fibers have a very tiny core. Light travels in a single, straight path, like a laser beam. This means the signal can go very far. It's great for long-distance communication. Think transoceanic cables connecting continents, carrying huge amounts of data beneath the waves. These are the champions of long-haul data. Another type is multi-mode fiber. These fibers have a bigger core. Light can travel in many paths at once. It bounces around in different ways. This is good for shorter distances. Like connecting computers in a building or on a campus. They're often easier to connect and a bit less expensive. But the signal doesn't go as far as single mode without needing a boost. Plugging in, understanding cable sockets. Cable sockets are very important. They are the connection points. Think of them as special doors. These doors let signals pass from a cable to a device, or from one cable to another. Without good sockets, the signals get lost, or they become weak and unclear, so socket design matters a lot for everything to work smoothly and reliably. Sockets need to be designed carefully. Electrical conductivity is key for metal wires. This means electricity flows easily without resistance. For fiber optics, precise alignment is crucial. The tiny fibers must line up perfectly or light will escape. Sockets also need a strong mechanical fit. They should not wiggle or fall out easily. They must also resist heat and corrosion, which is like rust. You have seen many types of sockets. RJ45 sockets are for internet cables. You plug them into your computer or router. For fiber optics, there are LC, South Carolina, and ST sockets. These connect fiber optic cables carefully. USB sockets connect many devices like phones and printers. HDMI sockets are for your TV and game consoles, carrying picture and sound. Each socket is designed for its specific job. Let's look at the USB-C socket. It's a newer type of USB. It is small and oval-shaped. A great feature is that it's reversible. You can plug it in upside down and it still works. No more fumbling. USB-C can carry data very fast. It can also carry power to charge devices. It's becoming very popular for many gadgets, from laptops to smartphones. Making connections work, sockets and system performance. Fiber optics have many advantages. They offer super-fast speeds for data. This is much faster than old copper wires. Signals can travel very long distances in fibers. They also have much higher bandwidth. This means they can carry more information at once. Plus, they are less affected by interference from other electrical devices, giving cleaner signals. So what else are fibers used for? We know about internet and TV, but they are also in medical science. Doctors use them in cameras to look inside the body. This is called endoscopy, helping diagnose problems. Some buildings use them for cool lighting effects. They are even used in sensors for safety in bridges or airplanes. Their uses are growing all the time as we find new ways to use light. What makes a connection good? This is about output criteria. For networking, it means a strong signal. Data should transfer without errors or loss. You want fast downloads and smooth streaming videos. For video and audio, it means a clear picture and crisp, clean sound without any static or distortion. Good connections make our technology enjoyable and useful. In fiber optic systems, good output means minimal light loss, especially at the sockets where cables connect. The light signal must pass through cleanly and strongly. For electrical systems like your home wiring or device chargers, it means good contact. Low electrical resistance is also important. This ensures power and signals flow efficiently and safely. All connections must be reliable to keep things working right.